guys, welcome back to another video tutorial. Today I am going to share with you another interesting topic on MXenes. Through this video I am going to share some of the basic information about MXenes and its properties, how we can synthesize MXene in the laboratory, and finally the application. Okay, so let's start. Basically, MXenes, a new family of multifunctional 2D solid crystals which contain large class of transitional metal carbides, nitrides and carbonitrates with properties like metallic conductivity, hydrophilic nature as well as excellent mechanical properties. Okay, so these MXenes were discovered by Barsoms and co-workers in the year of 2011. MXenes are produced by exfoliation of selective max phases. So the max phase is the MXene precursor, which have defined stoichiometry as Mn+1 So where n is the numerical number, in which m is the d-block transition metal, and A represent group 13 and 14 elements, and X is the carbon, nitrogen or both. Okay, so this phase has a hexagonal structures where the layer M and A are intercalated, and the X atom are located into the octahedral side formed by M element. Okay, so this MXene typically have three different formulas like M2X, M3X2 and M4X3. Okay, so these are some basics about MXenes. Okay, so because of these 2D structures, it have different properties like high metallic conductivity, hydrophilicity nature, low diffusion barrier, high ion transport properties, biocompatibility, large surface area, and ease of functionalization. So because of these kind of properties, these MXenes we can use in wide range of applications like energy storage application, water purification, biomedical application, and finally environmental applications. Okay, so and next we will discuss about how to buy these MXene in the laboratory. So similarly, similar to other 2D structure, nanostructure synthesis approach, this MXene also we can synthesize by two approach, that is top-down approach and the bottom-up approach. Okay, in this both strategies have been performed on the fabrication of single or few layer or multi-layer nanostructure of MXenes. Okay, in this first one is top-down synthesis. In the top-down method is based on direct exfoliation of the bulk crystals. So for the exfoliation we need various driving forces which include mechanical and chemical exfoliations. Okay, for the general and common MXene fabrication is based on liquid phase exfoliation. So in this picture we can see that liquid phase exfoliation process. So this is one of the commonly accepted production method for ultra-thin nanoscale MXenes. Okay, and in this synthesis approach there are two steps there to transformation from parent max phase ceramic into nanoscale 2D MXene. Okay, so the first step is delamination. So here this hydrofluoric acid based etching is used to obtain a multi-layer stacked MXene. And the second step is the disintegration by organic base molecule interaction or zonation to acquire a few layer or single layer MXene. Okay, so these are the two steps in the liquid phase exfoliation process. Okay, finally we get a single layer or multi-layer MXenes. Okay. In the second approach is bottom-up synthesis. So in the bottom-up approaches, these are alternative method to produce 2D nanomaterial via atomic level control of their components and morphology. Okay, so similar to other nanomaterial synthesis, means 2D material synthesis, this MXene also can synthesize by chemical vapor deposition, sputtering, and thermal deposition approach. Okay, so these all about the synthesis method for MXene. Next is surface modification. So the MXene have common features like its surface have specific surface terminations, which include hydroxide, oxygen, or fluorine. Okay, so because of this surface termination, it have high surface charge. That is, it has negative zeta potential of which exceeding minus 40 milliwatt. Okay, so because of this high surface charge, it have high stability of surfactant-free water-based colloidal solution. Okay, so even though it have high stability, it get rapid aggregation and precipitation in biological medium when we use it in the biomedical application. Okay, so that is one of the major limitation, major problem in the MXenes, especially these delaminated ultra-thin MXene are unstable in the physiological condition. Okay, so what we need to modify the surfaces. So in common, the surface modification of MXene have been focused on two approaches. One is polymer-based strategy. Another is decoration with inorganic nanoparticle. Okay, and the first one is modify with polymer-based material. So in this picture, we can see this MXene surface is polymer, means like modified with polymers like PVP, PEG, like other biocompatible polymer. So that by how it binding means by non-covalent binding. So we can simply stir or heating with this polymer. We can easily functionalize the surfaces of MXenes. Okay. And the second approach is decoration with inorganic nanoparticles. So the inorganic nanoparticle like iron oxide or other MnO2 or any material means nanoparticle, inorganic nanoparticle we can use to decorate the surfaces because it have high different surface terminations. So you can decorate with the different inorganic nanoparticles. Okay, so this is all about the surface modification and functionalization of the MXene. Okay, applications. So we already told that the MXene have different properties. So because of these different properties of the MXene, we can use in different applications such as energy storage applications, water treatment application, environmental remediation, and nanomedical medicine application. Okay, so the properties like high electronic conductivity, tunable structures, different functional termination, and adjustable component, and interlayer spacing. Okay, because of these kind of properties, we can use this MXene in energy storage applications like supercapacitor, lithium-ion batteries, sodium-ion battery, and lithium-sulfur battery, etc. Okay, so next is we can also use this MXene for water treatment application. So this MXene is used act as a adsorbent or membrane or an electrochemical separator. So any of these means for this all we can use the MXene. Next, the environmental applications like we can use this MXene structure and this 2D structure as a photocatalytic activity, antimicrobial activity, and we can also use this structure as a sensor. Okay, so this all about some of the application. And next is because of the hydrophilic nature and biocompatible compatible nature and ease of functionalization of the 2D surface, we can use this material in biomedical application. Okay, like diagnostic imaging, therapy, biosensing, and antimicrobial activity. Okay, so this is all about the application part of MXene. So here I will discuss some of the application in detail. Okay, the first one is therapeutic application of MXenes. Okay, so the first one is photothermal therapy. So I already shared a tutorial about photothermal therapy. So I shared the link in the description box. So if you want to know more about the photothermal therapy, please look on the link. Okay. So next is so in this photothermal therapy. So basically it works based on the photothermal agent which accumulated in the mutated cell region and which absorb the NIR light and convert it into heat. So that heat is more than enough to kill the cancer cells. Okay, so in the photothermal therapy, basically, and there are the photothermal conversion are determined by two important parameters. One is extinction coefficient, and another one is the photothermal conversion efficiency. Okay, so the extinction coefficient, which reveals the light absorption capacity of the photothermal agent, and the photothermal conversion efficiency, that indicate the performance of agent in converting the light into heat. Okay, so a group of researchers, they developed a titanium carbide based nanosheet which exhibit a high extinction coefficient and which have high photothermal conversion efficiency than the current AU nanorod, because the AU nanorod is widely used as a photothermal agent. So this titanium carbide based nanosheet which have 30.6% higher than that of the AU nanorod. Okay, that is the photothermal conversion efficiency. So because of this titanium carbide nanosheet can rapidly convert the NIR light into heat. Okay, so this is all about the photothermal therapy. Next is the synergistic therapy. So in this is a combinational therapy of two or more drugs which can give combined effect. So this combined effect is greater than the sum of the effect seen when each drug is given alone. Okay, so in this picture we can see a titanium carbide based 2D MXenes. So that is decorated with chemo drugs. Okay, so both these placed in the tumor site. So by NIR means external NIR laser source, it can release the drug molecule and it can act as a photothermal agent. So both this therapy is done at the same time. Okay, so as the result, the effect is very different from the individual therapy. Okay, so for that we can use this 2D nanostructure. Next application is imaging. So the MXenes we can use in the diagnostic imaging because diagnostic imaging like CT, MRI or photoluminescence means fluorescent imaging. So we can use this MXene as a contrast agent to enhance the diagnostic imaging performance. Okay, so the conventional 2D contrast agents which have some limitations, but the 2D MXene based agents which have different properties like it have good quantum size effect for photoluminescence application and the element enhanced contrast for X-ray CT imaging and effective loading and functional contrast agent for MR imaging. Okay, the first one is the fluorescent imaging. So a group of researchers, they developed the ultra-thin graphitic carbon nitrides based MXenes, so which exhibit high photoluminescence and for intracellular bioimaging. Okay, so another one group, they developed the titanium carbide based MXene quantum dots, so which also provide high quantum yield than the conventional one. Okay, so that we can use for the cellular imaging. Okay, next is computed tomography imaging. So this is one of the widely used medical imaging technique in worldwide. So in this the nanomaterial which contain high atomic number element have been explored as a CT contrast agent. Okay, so for that this tungsten sulfide tungsten disulfide based MXenes were used as a contrast agent for CT imaging because the tungsten have an atomic number of 74, which is superior than the conventional contrast agent element. So okay, so and another case, the bismuth based, that is the bismuth selenide based 2D structure is used as a contrast agent, so which have higher atomic number, that is 83, so which will be favorable and contrast agent for the CT. Okay, so this is all about the computer tomography imaging. Next is magnetic resonance imaging. So because of the high spatial resolution and excellent contrast difference of 3D soft tissues and non-invasive features of the MRI have been extensively applied for clinical diagnosis imaging. Okay, so this a group of researchers, they developed a titanium carbide with the integration of MnO2 based contrast agent for the MRI for it shows which has been investigated for diagnostic tumor MR imaging, so which provide very enhanced means imaging in the MRI. Okay. Next is biosensing application. So these 2D nanostructures are widely used in biosensing application. So here, because of the hydrophilic surface and metallic conductivity and planar atomic structure, which this 2D structure can use as a field effect transistor for fast, direct and label-free analysis of biological events. So recently, a high-sensitive device based on the MXene FIT-based biosensor, which shows high sensitivity and label-free detection of dopamine, and which can monitor the spiking activity in the neuron. Okay, so that is also one of the application. Another one application is we can use this MXene as a antimicrobial activity in applications, like various in general this antibacterial activity. Various 2D nanomaterials have been explored for their potential antibacterial activities. So here a group of researchers they used titanium carbide based 2D structures, and they find which have high antibacterial activity towards E. coli, and comparison with the graphene oxide, because graphene oxide shows good antibacterial activity. So okay, so this is all about applications of MXenes. So that's it. Okay, thank you for watching this video. I hope you gain some information about what is MXene, its properties, how we can synthesize the MXenes. If you like this video, please share with your friends and contacts. Thank you.